now that it's time to start, let's look at the infrared image for Hurricane Elsa. Doesn't look like a hurricane. In fact, I would actually think it looks like a tropical storm. It's not very well organized. There's quite a bit of disorganization, the thunderstorm activity, displacement. However, the winds have been at hurricane force. Let's go to aircraft recon, and I'm going to show you what I'm talking about. As you can see, the air pressure is 999 millibars, which is pretty high, but it is moving northwest. It is moving, so it looks like it may indeed take the northern track. And looking at the winds, let's look at the last recon mission. Mission 3, that's upper reconnaissance mission. My theory is that Elsa will traverse southern Hispaniola, up southern Haiti, go into Cuba, and then go up the coast. I do not believe it will make landfall on the Gulf. I believe an East Coast strike is pretty likely now because it's stronger. It will end up heading further east because of that. So I believe that, yeah, this is unlikely. This is fairly unlikely tomorrow. And so looking at the weather for Sunday here in Northeast, it's going to be some thunderstorm activity tomorrow. Monday, so looking at Wednesday, and then, yeah, Thursday's just going to be a mess. Friday's going to be better. So let's look at the National Snow Ice Data Center. I just want to talk about the Arctic sea ice concentration, which I'm very concerned about because climate change is really like rearing its ugly head right now. It's really getting worse. We already hit our earliest 5th named storm on record. Yeah, this is even earlier than last year, and even earlier, much earlier than 2005. So last year was early, we broke records. It's even earlier this year. Yeah, and look who wrote this. Jeff Masters, the head of Weather Underground. Yeah, this guy. He's like the best. I freaking love Dr. Jeff Masters. Yeah, he is actually world famous. Yeah. He writes about extreme weather and climate change for the Scientific American. He, in 1995, co-founded Weather Underground. I actually started using Weather Underground all the time. Yeah, so sustained winds of 63 gusting to 86. And guess what island is also being impacted by this storm? This is going right towards St. Vincent. This is just before it became a hurricane. Well, she became a hurricane. And look what island was hit. St. Vincent actually got nailed by this storm. You see, oh, why don't I follow him? He's amazing. Yeah. Past just north of St. Vincent. Yeah, St. Vincent got hit. Yeah, in modern history. Yeah. Do you see this here? Those are thunderstorms. These are cumulonimbus clouds. Yeah. Look at this, like incredibly, just incredible. Look at all the storms, all these storms here. Like, the hope is that they're gonna put out rain that's gonna shut off the fires. But the main concern with all these fires, all these storms, is they'll generate more lightning and cast more fires. This pyrocumulonimbus, these are like animals. So they can not only generate more fires, start more fires, but they can also generate severe weather, such as large hail, damaging winds, even tornadoes. And yeah, so pyro-generated thunderstorms can not only start new fires, but in rare cases can even cause flooding. Yeah, so you're dealing with the fire, and then the fire causes a storm that can deal with flooding. That's very rare, but But yeah, this is a massive storm cluster. You can almost call this a mesoscale convective complex, or MCC, because this is a massive storm complex. You're probably having a storm system coming through already. So the atmosphere is already primed, and then you're having these fire-generated storms, which just exploded the whole atmosphere. Because the fires are here, right? This is where the fires are. And I don't think the fires are generating all of the storms. I think some of these storms are forming on their own because of the environment, like the storm system coming through. Let's see. Boom. Oh yeah, no, these are generated by thunder fires. Wow. The hope here is, oh yeah, oh, a lot of lightning there. But you see how most of the lightning is well downwind of the thing is, most of the lightning, if you notice, is well downwind of the fires. So already you're having cumulonimbus clouds here, but most of the lightning is in this little area here. It's because it's a cell, basically. So basically, the fires are generating severe thunderstorms or extreme thunderstorms, and then you're basically having, well, thunderstorms forming. Wait, do you see that right there? Yeah. And right there you have a non-fire generated thunderstorm right there, boom. So you see the fire is here. This is the fire. You're having one fire and then just regular thunderstorms. A non-fire generated thunderstorm right where my arrow is. Fire generated, fire generated. Boom. But see, not all of the storms were generated by the fires. These two were. But you see, look, right here. It's fires, but no storms. Storms from the fires, but you also have thunderstorms being generated here, see? Anyway, let's go back and focus on Hurricane Elsa. Elsa right now is a Category 1, I believe. But may be downgraded to a tropical storm. Why am I thinking she may be downgraded is she is losing her convection right now. The convection is very discombobulated, very disorganized. There's clearly wind shear going on, not very healthy outflow. So because of this, I'm thinking that Elsa will be downgraded shortly to a tropical storm. She could be upgraded again, but unlikely. Yeah, so you see lightning activity around the eye here. So basically, this is how the storm progressed. So this is basically the center of circulation is in this area here. You want to look at the winds, the way the winds are flowing around the storm. So the center of circulation is most likely somewhere in that thunderstorm cluster. But it's very disorganized. The reason for that is A, there's wind shear, B, there's some dry air. However, this is also early in the hurricane season, so the water temperatures have not hit their prime. Water temperatures have not hit their prime. They had not hit their maximum possible temperatures. So even though, you see, this is when she was considered to be a hurricane. So again, you're having more thunderstorm activity. So very strong winds, but high pressures. The thing is, let me show you Elsa. Hurricane Elsa, 995 millibars. Very, very high pressures for a hurricane. Like, I've seen tropical storms with 900 sub 980. So something's telling me that Elsa is not going to maintain hurricane strength for long. And I now believe that the National Weather Service is absolutely right by maintaining such a low intensity up to landfall. I do not think Elsa is going to become a major hurricane. Extremely unlikely. Let me see if Galveston is going to be on the list. Galveston. This is the Galveston hurricane of 1900. 1938. You see pressures? Yep. This is the hurricane. You know, the Great New England hurricane. Of course, they're not mentioning it. Anyway, yeah, that's kind of unfortunate. Anyway, let's look at. Just want to look at Campi Flegrei right now. Looking at the seismic information for Campi Flegrei. So there was a pretty sizable earthquake earlier. 1.6, that's a smaller one there. 1.6. There were no quakes since then. Yeah, as you can see, that was it. We had 1.6 and that was it. Mostly because of uplift. This is what the weather's going to be like today. So through early afternoon, you'll have some thunder showers, and then you'll have some convective activity, a wraparound convective activity. I don't think it's even going to break 70 degrees in New York City today. It's going to be in the low 60s throughout the day. If you want convective activity, you've got to go like western Pennsylvania, like eastern PA. That's where they'll have some convective activity, basically. Go to convective precip, you'll see what I'm talking about. See, cold air aloft. It's going to be very cold aloft. However, right, I'm not going to do this live stream for much longer, but I'm going to look at Elsa one more time. So it looks like there's a possibility that Elsa may try to go up the East Coast. May. It's not its will. It may try to go up the East Coast. It actually looks more likely now. This is the GFS. Yeah, it looks like the trend is more into the Gulf now. I'm going to try to look at the European. West-northwest at 29 miles an hour. Very fast moving. Skip. Okay, let's look at the North Atlantic. There's Elsa. There's our Elsa. It looks like it really looks like Elsa's going to be going up the coast. Yeah, look at that. Ensembles, European ensembles. Yeah, it looks like Elsa may just go up the coast. Anyway, so let's look at that. Let's look at the Atlantic imagery. Looks like we have another tropical wave coming off the coast of Africa. So future hurricane there, future system there. So very active. The Cape Verde Atlantic hurricane season is very active. It's very early actually. This is actually I believe the first Cape Verde system. Most of the others were frontal systems. Let's look at 2021 Atlantic hurricane season. Anna, basically formed from a frontal system, non-tropical low, basically came in from the Pacific, so not Cape Verde. Yep, dissipating cold front. This is the first Cape Verde system of this year. First Cape Verde system, basically. This is the second tropical system, formed from the tropics. This is I believe this first one. Tropical low in the Gulf of Mexico. Yeah, initially this has moved slowly to the south. Wait, trough of low pressure. Okay, noted the possibility of a trough of low pressure developing the Campi. Yeah. Yep. Anyway, thank you for watching. So yeah, have a great day. Bye. Oh yeah, this is what's unusual about the system. It made landfall as a tropical system, right? Well, subtropical. And then was a potential tropical cyclone here. Became a depression and then became a tropical storm over land. Like it strengthened over land. Let me see. Hold on. Early on June 21st, Claudette re-strengthened the tropical storm while still located over northeastern North Carolina. Do you see that? It re-strengthened over land. That is very unusual. But this was because of undergoing cyclogenesis. It was undergoing extratropical cyclogenesis, and that gave it a boost because it was still tropical, even though it was undergoing extratropical cyclogenesis. It strengthened back into a tropical storm as it was transitioning to a non-tropical low. Basically, that's what basically happened. Well, thank you for watching and have a great day. Bye. Ending the stream right now.